Okay, this video is just going to be a quick little intro to right triangle trigonometry. So, that pops up all the time. So for right triangle trigonometry, we're going to be working with sine, cosine, and tangent, and it's going to work with SOHCAHTOA. Probably something you have heard before. Okay, but SOHCAHTOA ultimately is your sine, cosine, and tangent. But the rest of the letters represent your answer for what sine, cosine, and tangent are equal to. So is actually going to mean that sine of an angle, in this case we're going to use theta as our variable, is equal to O over H. Cosine of theta is equal to A over H. And tangent of theta is equal to O over A. There's your SOHCAHTOA. It's just to help you remember that idea. Okay, so SOHCAHTOA will get you all of that information. And what the O, A, and H represent: O is your opposite side. A is your adjacent side. And H is your hypotenuse. So we're actually going to go over the hypotenuse first. Hypotenuse is always the longest side of the triangle, and it's going to be across from the right angle. So our right angle is this one right here, 90 degrees. So that means this over here is the hypotenuse. At this point in time, we can't see for sure that that's the longest side, but I'm going to show you the math to figure out what the actual measure of that side is. But we do know it's the hypotenuse because it's directly across from the right angle. Okay. Everything else is based on where your angle is. In this case, our theta is in the bottom right corner of our triangle. So the opposite side to that angle is going to be, on the opposite side of it. Just like this, when you draw that over, this is going to be the opposite from theta. And adjacent just means next to. So your adjacent side is going to be the side that is next to theta, which is going to be this 3. That is our adjacent side. And again, this over here was our hypotenuse across from the right angle. Okay, so before we can actually configure all of this, we need to figure out what the hypotenuse is. We have a triangle with a missing side. So that's going to bring us back to something called the Pythagorean Theorem. Which is just a squared plus b squared equals c squared. So now we're literally bringing in 3 variables, and we didn't really talk about where those would be on the triangle. So let's go over that real quick. Okay, so for the Pythagorean Theorem, you need your A, your B, and your C. The most important thing that you know is C. C is going to be your hypotenuse, always, no matter what upside down triangle, whatever you're looking at. C is going to be the longest side, which is always your hypotenuse. The other 2 sides can be A or B. It doesn't matter. Just know that if this one is A, this one is B. If this is A, this is B, and so on. Like, they have to be opposites of each other. They can't both be A. That's the whole idea there. But C has to be your hypotenuse. So in order for the Pythagorean Theorem to work, you need to know 2 of your sides, because we do have 3 variables. To find the 3rd variable, you need to plug in for 2 of them. So in this case, we are good. I'm going to use 3, this side length right here, 3, as my A, because it's adjacent. I feel like that just kind of fits. So it's going to be 3 squared plus, that means B is going to be the other side length, which is 4. So 4 squared. And that's going to be equal to, I'm just going to leave it as C squared. Some people like to make this an X squared because they like solving for X. It doesn't really matter. Okay, but the goal here is to solve for C. So I can simplify this whole left side here. 3 squared is 9. 4 squared is 16. That's equal to C squared. And 9 plus 16 is 25. That's equal to C squared. And I'm going to take the square root of that to get rid of that squared. So I can get C by itself. And the square root of 25 is a plus or minus 5. Okay. Because we're working with shapes, The square root of 25 is actually only going to be positive 5 because we're talking about the side length of a triangle. You can't have negative 5 units, whatever this is, inches, feet, who cares? It's not going to be negative 5. So my hypotenuse is going to be 5. And now I know all three sides of my triangle. So now I can go back to that SOHCAHTOA and actually get into these questions over here. Okay, so first is sine. Remember, sine is so, which is O over H. So I need opposite over hypotenuse. The opposite is 4, so it's 4 over the hypotenuse, which is 5. And there's my answer. The sine of this angle, based on this specific triangle, is 4 over 5. Sorry, that pops up a lot. Okay, C for cosine is ca in SOHCAHTOA. That's going to be A over H, which is adjacent over hypotenuse. So my adjacent side is 3, and my hypotenuse is 5. So that's it. My cosine is 3 over 5. Okay, tangent is TOA, so opposite over adjacent. So my opposite side was 4 over my adjacent, which is 3. So 4 over 3 is the tangent of that angle. Typically, they want the answers as fractions. If the directions say to like round to the nearest tenth or something, you would just do 4 divided by 3 in your calculator. Okay, 4 divided by 3 is just 1.3 repeating. Hopefully you maybe knew that without the calculator, but to the nearest tenth would just be 1.3. If it asked for something like that, just for instance. Okay, so let's try another one of the same type of problems. Okay, but this one's kind of like a weird looking right triangle. Like we said before, the most important thing is that you know where theta is. So theta is that angle right there. So now I need to label my opposite, adjacent, and hypotenuse. So opposite is always opposite side from theta. So this is going to be the opposite. Adjacent is the side next to it, which might seem kind of crazy for this one because this 9 is also next to theta, but the 9 is going to be your hypotenuse. Okay, usually you find hypotenuse first, and I really should have. Your hypotenuse is across from the right angle, and then opposite and adjacent, obviously adjacent's next to. Yes, this one's next to also, but it serves as your hypotenuse because 1, it's the longest side of the triangle, and 2, it's across from the right angle. Okay, just like the last example, we need to find our missing side before we can do anything here. So our missing side is over here, the opposite. I don't know what that length is, so I need to find it. I do have 2 other sides of this triangle, so I'm going to use the Pythagorean Theorem again to find that missing side. Okay, but for this one, I'm not trying to find the hypotenuse. I actually know what the hypotenuse is. The hypotenuse is 9, and the hypotenuse is C in the Pythagorean Theorem, so I'm going to plug that in there. The adjacent can be A or B. I'm going to stick with using it for A because it's adjacent. B is the thing that I don't know, so I'm going to bring that down. It's still a regular equation. I can easily solve for this, but it's like 1 step longer maybe. I do need to square each one just like I did in the last time. 4 squared is 16. My plus b squared comes down, and 9 squared is 81. Okay, but for this one, they're not on the same side, so I can't just add them together. I'm going to have to move the 16 over. So it's a positive 16. I'm going to subtract 16 from both sides. So that'll give me that b squared is equal to 81 minus 16 is 65. Then we run into a little bit of an issue. To get rid of that squared, I'm going to take the square root of both sides. And unfortunately, like these will cancel and get me b equals, but unfortunately the square root of 65 is not a nice number. The square root of 65 is a long, irrational decimal. So I'm just going to leave it as the square root of 65, and that's what I'm going to put right here. Okay, I wanted to give you one with an ugly example so you kind of had an idea in case you see something that comes up like that. Okay, so now I have my 3 sides to work with, and I can do SOHCAHTOA to find the answers down here. So sine is opposite over hypotenuse. The opposite side is square root of 65. Again, I know it's ugly, but it could happen. And the hypotenuse is 9. So that's my answer. Square root of 65 over 9. It's as simplified as it's going to get. Cosine is ca, so adjacent over hypotenuse. The adjacent side is 4, and the hypotenuse is 9. This answer is much nicer, 4 over 9. And then tangent is opposite over adjacent. The opposite side from theta is the square root of 65, and the adjacent is 4. So the square root of 65 over 4. That's all there is to it. Okay, we're going to get into a little bit of a different type of SOHCAHTOA question, and it's going to be a word problem. Okay, so at 57 inches from the base of a building, you need to look up at 55 degrees to see the top of a building. What is the height of the building? Okay, so definitely going to want to draw a picture for this to visualize where a triangle would be and what measurements are where and all that good stuff. Okay, so 57 inches from the base of a building. First thing I heard that I need to draw is a building. So here's my building. I put a little door there and some windows. Isn't that a nice building? I'm an artist. 57 inches from the base of the building. So the base of the building is here. If you're 57 inches from the base of the building, that's going to be a horizontal line on the bottom. Here you are. And that is 57 inches away from the building. So that red line I just drew is 57 inches. Okay, so I read on. You need to look up at 55 degrees to see the top of the building. So you got these cool eyes right here. And they're looking up at the top of the building at an angle of 55 degrees. So that angle in here is 55 degrees. We haven't really looked at a problem like this yet, where we're given the angle. Okay, and then the last part of this word problem says, what is the height of the building? So the height of the building is just going to be this line right here. That's the thing we are trying to find. It's unknown. But I have my right triangle because right here at the base of this building, where the building meets the sidewalk, as long as the building is standing up straight, is going to get you a 90-degree angle. Okay, so if we're missing the height of the building, take a look at what you have here. This is what we were otherwise looking at as theta, but now we actually know the measurement, but that's still the angle that we're referring to. So look at the information on this triangle that you are, investigating. We have this side right here, which is the adjacent, and we need to find this side over here, which is the opposite. One of the other sides we don't know is this over here. This is our hypotenuse, but because we have two pieces of information, the 55 degrees and the 57 inches, we're going to be able to use SOHCAHTOA to find this opposite side. Okay, because even though we don't know it, it is one of our sides that we're looking into, so we're talking about the opposite and the adjacent. Hypotenuse has nothing to do with this problem. So if you're talking about O and A, which trig function would that be? Tangent. Tangent is TOA, opposite over adjacent. And again, we have opposite and adjacent in this problem. I know we don't have the opposite number, but we're going to use what we have in the problem to get it. Because for this one, I know it's very different than the last couple examples we've done, but I have this 55-degree angle. Instead of theta, I'm going to plug in 55 degrees here, so it's not my variable anymore. It's the tangent of 55 degrees is equal to the opposite, which is, I have no idea, I'm just going to call it x, over my adjacent, which is 57 inches. So see how for this one we actually didn't need the hypotenuse, because when we plugged in 55 and we plugged in 57, we only have one variable remaining. So we can now use our math skills to find out what x is. Okay, so to get x alone, right now x is being divided by 57. To undo that, I'm going to multiply both sides by 57 so that those will cancel out and you get x by itself. So all you'll have to do is plug this into your calculator. 57 times the tangent of 55 degrees. Practice plugging that in for sure, but you should get 81.4. So because this is a word problem, definitely make sure that makes sense. 81.4 would be in inches, and it would be the height of the building. So that's definitely a possibility. 81.4, and I know it's inches because this was measured in inches right here, so we got to stay consistent with that. This is just going to be 81.4 inches for the height of the building. So that's just a little bit of a variety for some right triangle trigonometry problems you could see with a word problem, just so you can kind of get the gist of SOHCAHTOA, and we can dig more into